Alright, in this video I'm going to walk you through how to program your graphing calculator to solve this problem. This is a semi-famous probability problem that I created a solution for and an algorithm to accompany that solution. So we're going to take this algorithm and use it as the basis for a program in the TI-83 graphing calculator. Okay, so let's first introduce the problem. It says, ignoring leap years, find the probability that a room containing n people has at least 2 people with the same birthday. That's the same month and day, not the same year. The solution I wrote for it was basically this. Probability that at least one pair of matching birthdays exist in the room will be equal to 1 minus the probability that no one in the room has the same birthday. Alright, if that's the case, then that will work out to be 1 minus 365 divided by 365 times 364 divided by 365 times ... 365 minus n plus 1 divided by 365. If you want to see how I came up with this solution, go to statsprofessor.com and read the blog post that I created for this problem. Alright, let's use the algorithm then to try to program these steps into the graphing calculator. Alright, so here's my graphing calculator. So step 1, it says establish n, the number of people in the room. Well, to put that in the calculator, what I want the calculator program to do is kind of prompt the user for n to say what room size are you dealing with. So let's go into program first and start the program. Now, when you enter the program menu on the graphing calculator, which is here, this button program, you're going to come to this screen. Now, my screen doesn't have any programs in it, so I'm going to go over to where it says new and create a new program. So I'll press enter, and then I need to type the name in. Now, it already has the alpha icon up there, so these little green letters is what I'll use to type the name. I'm going to call this program birthday. So I'm going to enter B-I-R-T-H-D-A-Y. There we go. There's birthday. Once this checkered sort of cursor comes up, it's telling you have no more space in the calculator to continue the name. So I'll press enter, and there's the name for my program, birthday. Okay, so here we are in our first line of code. So it says establish n, the number of people in the room. Well, I want the calculator to sort of let the user know that they need to enter n into the calculator. So I'm going to display a message on the screen to the user when they come in here. To display, I'm going to go to the program menu. There's a control option here which has statements like if, then, else, for, while, repeat, end, etc. Those are things that people familiar with basic programming should be familiar with. We don't need this at this point though. We need to come over here to I/O, which is going to represent input-output. So if I want to display something, for example, I'll take option 3. Now, display, I can display text by putting alpha and then coming over here where these quote symbols are above the plus key. And I can enter whatever text I want. So I'm going to say enter room size, and that will display to the user as a phrase saying enter room size. So I'll do alpha E, alpha N, etc. So I'm just going to type all this in quickly and then we'll come back. If you need to enter a space, you have this little space key right above the 0. So you do alpha space. Okay, so I've entered in the full phrase now, enter room size. I'll press enter. If I want to see how this actually works, what I'm going to do is simply quit out of the program by doing second quit, and then I'll press the program button, and I'll do execute birthday by pressing enter on this first screen after you push the program button. And now if I hit enter again, it'll begin to run, and you can see what it's going to do. It's just going to put out the statement enter room size. And it says done because that's all the program is doing at the moment. So you can see you can always test what you've done so far and make sure it's functioning properly. Then you can just hit program, go to where it says edit, and then continue to work on your program. So I'm coming down to the next line. The next line says to store n in a variable called n, it says, right? Store n in a variable called n. Now the calculator already has n, so what I need to do is basically figure out how to get the value for n into this. Well, that's going to come from the user, so in order to do that, I need to basically prompt the user, right, for a variable. And the way I'm going to do that is I'll press the program menu, come over to input-output again, because that's something someone's going to be inputting into the program, and I take option 2, which says prompt. And the way prompt works is it's going to ask the user for whatever variable we enter here. Well, we want it to be entered into n, so we're going to say alpha n. I'll press enter, and let's go ahead and test that. So I'll quit out of here, clear the screen here, I'll press program, execute the program. It's going to say enter room size. So I say 23 is our room size. I press enter. The calculator just says done because it's not doing anything after we have the room come up. But at least we have it entered. We can confirm that's been done properly by hitting alpha n. and then enter, and you see 23 appears, right? So 23 has been stored in the variable n. All right, good. Let's go back to our program, edit, enter, here we go. So we've got prompt n up on the screen. Now we need to create a count variable called c. We don't actually have to do anything in the TI-83 to do that, so we're not going to really worry about that. C already exists. This is already designated in the calculator as a variable. And it says initiate the count variable to 1. So how are we going to initiate it to 1? Well, we have a store feature in our calculator that you might have used when doing calculations. If you just do 1 store 1 into, that arrow is telling you put the 1 into something. We want to put it into c, so alpha c. So this is kind of a dummy variable. The calculator, when it runs the program, will automatically initiate c with 1. All right, let's tackle step 5 now. It says create a variable called f to store our probability fraction and initialize it to 1. Okay, so we're going to create a variable called f, and we're going to initialize it to 1, just like we did with c. So basically we'll do 1, store that value into a variable called f for fraction, of course, right? All right, press enter then. All right, so let's look at step 6 next. In step 6, it says check if n is greater than c. If it is, advance to step 7. Otherwise, proceed to step 11. Let's read a little further, though. It says, if we go to step 7, it says perform the following calculation. All right, so they're going to do f times this fraction. And both f and c at this moment would be 1 because we haven't done anything yet, right? So it would be 1 times 365 minus 1, or 1 times 364 divided by 365. If you think about what's happening here, 365 divided by 365, that's 1, so that's like our f. And then 364 times 365, that's the fraction that will result when c is plugged in as 1. So we've got sort of 2 people in the room at that point, right? And then it says store that result of the calculation from step 7, right? So this calculation into the variable f. So we're going to take this information, whatever it turns out to be, whatever that calculation yields, and we're going to store it into f. So f is going to change its value. And then it tells us to increase the count by 1. And then we come here and return back to step 6. That's what I was looking for, this return back to step 6. This returning back to step 6 indicates a loop is happening here. So we need a loop. And not only that, we need a loop that's going to run based on a condition. For those who are a little bit familiar with basic programming, that's called a while loop. So what I'm going to do here is I'm going to just go to the program menu and see if I have anything in this control menu that has something like a while loop. And of course 5 is pretty intuitive, it says while, right? So I'll press enter. And now in order to tell it a condition, I'm going to use a parenthesis now. And in this parenthesis I'm going to state our condition, while n is greater than c. So I'll say alpha n. Where am I going to get the greater than symbol? It's actually under a menu here. So if you hit second, test, so second because it's in yellow, test, that's where the math key is, you have all these inequality symbols. We're going to take number 3, which is greater than. So while n is greater than alpha c, that's what we're looking for. Close that up, press enter. So what it's going to do is when the calculator hits this, it's going to keep running the commands after this while statement until this isn't true any longer. All right, let's look at the next step then, step 7. It says perform the following calculation. That'll be f times 365 minus c divided by 365. We'll enter it just like we see it. So it'll be alpha f times, open parenthesis, then 365 minus alpha c. Close it up, divide by 365. All right, press enter. For step 8, we're going to store the result of the calculation from step 7 into variable f. So we're going to take this expression and store it into f. So actually, I'm just going to come up here and do that and add it on to what we were just doing. Right? So all of this is just going to be stored into alpha f. The calculator will move left to right. So as it does this work, it'll finish it up, and then it'll take the answer and just plug it into f. All right, the next step says we need to increase c by 1. Well, how are we going to do that, right? Well, we can make the calculator do any math problem we want. So for example, I can say to the calculator, take c, so alpha c, and add 1 to it. But this is just a calculation, right? What I need to do now is tell the calculator to take the answer for this and store it back into c. So we'll make it go back into c. So 1 plus 1 now will become 2, and it'll be pushed back into c, which will increase c's value. All right, press enter, and then it says return to step 6. Well, how are we going to make the calculator know that that's the end of the loop? I wonder if there's a button in the program menu that can do that for us. So we'll go to Program, and luckily, if you look on the first control options, 7 says End, and it turns out that that'll work. So I press Enter, and the loop is done. So this is going to keep running over and over and over again until finally it's no longer true that n is greater than c. Finally, at some point, c will be equal to n, and it'll exit the loop here. Now, when that has happened, the calculation is finished. We have the answer, but the answer is stored in the variable f. But what is f really holding? Does it hold the answer to the whole problem? No, it doesn't. It actually just holds this piece here, right? All of these fractions multiplied together. It has that. We still need to do 1 minus f. So when we come out of that loop with f, we're going to do basically 1 minus f, and we're going to store that into a variable called a. So I'll have 1 minus alpha f gets stored into a variable called a. So again, the calculator will move left to right here and do 1 minus f and plug that into a. So you don't have to worry about putting any special parentheses. If you want to, you can always add a parenthesis in here. If you go second, insert, parenthesis, and then come over here, second, insert, parenthesis. Step 12 of our algorithm says that we should output a because it's our answer. And so that's why I called it a, obviously, for answer. Because basically what we've done now, we've done 1 minus this set of fractions. We stored that answer into our calculator. So I just need to display a. So remember, if I go to Program, I have this input-output feature. I can select option 3, which is to display, and then alpha a. And at that point, my program is done. So I can escape this by saying second quit, and I can test the program. So let's run the program a few times to get some probabilities. So let's check out the first kind of classic example. If I let the room size be 23, I let the room size be 23, the calculator says that it's 0.507. And the reason why this is famous is because it only takes 23 people in a room before you have better than 50% chance of having 2 people with the same birthday in the room. Seems shocking, but it's true. All right, let's run the program one more time. Program, birthday, press enter again to let it get going. Let's try 30. What happens if you have 30 people in the room? Calculator says a 70.6% chance. All right, let's try to up the room size just a little bit more. Let's try 50. What happens if you have 50 people in a room? By the time you get to 50 people in a room, you have 97% chance of having 2 people with the same birthday. One last calculation, one last value. What happens if you have 70 people in the room? That's not too big of a room, but a fairly big room. Wow, 99.9% chance of having 2 people in the room with a matching birthday. That's pretty impressive.